Okay, so in this section, we're gonna look at solving linear equations. Linear equations. Now, in the previous section, you learned how to graph linear equations. And notice that those linear equations that we graphed in the previous lesson had two variables, x and y, correct? This one, you're going to have something like this. It's going to look like 2 times 3x plus 1 equals 5 minus 3 times x minus 2. Notice that you only see one variable there. What's the variable that you see? What's the variable? X. All right. So this is a linear equation just like the previous lesson dealt with linear equations, except that one was graphing and this is not. Now, in the previous lesson, when we graphed those, we graphed the previous lesson, graph those lines. All of these points on that line was called a what? A what? A solution. They were called these solutions. How many solutions did this linear equation right here that I'm pointing to, how many solutions does it have? An infinite number. Okay? So we were basically solving this equation. So when you solve this equation, you're plotting your points, and it turns out to be this line. It has an infinite number of points. Here, you're also solving, but when we solve, do you remember how many solutions it's going to have? Remember a linear equation, when you solve the linear equation, how many solutions did it have? Do you remember, for the most part, it had how many solutions? It had one solution. This equation has one solution. This equation here has how many solutions? An infinite number. You can't list an infinite number of solutions, right? So you graph it. So that's what we're graphing. We're graphing solutions. All right, so when we do this one, we have to solve this equation for x. So it's going to say solve. So you're solving this linear equation. You only see what variable? X. All right, so the first thing you want to do, and we're going to look at this one first. First thing you're going to do, step 1 says to do what? Perform any distribution using the distributive property. The distributive property. So if you have parentheses, you get rid of the parentheses. So you got to remember what we mean by the distributive property. So what we're talking about was when you had something like this in a previous course. Suppose you had 5 times 3x minus 2, and you were told to multiply this. What property did you use to multiply this? The distributive property. And so basically everything inside the parentheses you'd multiply by what? 5. So this would be 15x minus 10. That's what you did. So to get rid of the parentheses there, you had to use the distributive property. That's what you do first here. So on the left side, how do we get rid of this parentheses? Multiply everything in here by 2. So 2 times 3x is 6x. 2 times 2 times 1 is 2. Make sure you write it mathematically correct. Some of you like to skip too many steps and it's all over the place. If I can't understand where you're going, you're not going to get full credit. Okay? Equal. All right, now, here's where a mistake will be. Some students are going to say, all right, 5 minus 3 is 2, and then distribute the 2. You got to remember the order of operations. I have subtraction. This is subtraction. This right here is what operation right here that I'm pointing to? Multiplication. What do you do first? Multiplication. So basically you're going to distribute first. So what are you going to distribute first? Negative 3. So I get 5. What's negative 3 times x? Negative 3x. And what's negative 3 times a negative 2? Positive 6. So that's what I get. Okay? All right. That was step 1. So step 1, I got rid of my parentheses. I had to use the distributive property. You're not always going to have parentheses. So will you always have to do step 1? No. Step 2 then says to do what? Combine like terms. So if I look on the left side, now you got to remember what like terms are. If I look on the left side, are these like terms? No. This has an x in it, this does not. This is a variable term, this is a constant term. They're not like terms. Over here, how many terms do you see? 3. Are any of them alike? Yes. Which ones are alike? What is 5 and 6 called? Constants. Good. 5 and 6 are called constants. Constants. So the first thing I did was I used the distributive property. And now I'm going to combine like terms. And when I combine like terms, what equation do I end up with? Well, I get 6x plus 2, right? Equal 11 minus 3x. Could someone else had written it as negative 3x plus 11? Yes, it does not matter. Notice how many sets of equations do you see so far? How many sets of equations do you see so far? How many sets of equations do you see so far? 1, 2, 3. There are 3 equations that you see, right? They're all equivalent to each other. I'm using the word equivalent. You're going to need that word on my math lab. Equivalent equations. Equivalent equations are equations that have the same solution. Same solution. That's what equivalent equations are. So basically what you're doing is, could you have looked at this equation here and right away determine the solution? Could only one person saying something? No. There's no way you could have done that. So you're doing using some properties to help you write equivalent equations so you can get to the point where you can determine the solution. So when I use a distributive property, the distributive property helped me to right away determine the solution. Can I look at this right here and tell me and say what the solution is right away? No. But those equations are equivalent because whatever that solution is the same thing as this one. Whatever the solution is here is the same one as what? That one. But I got to keep on going further until I can determine what it is. So that's what equivalent equations are. So let's find another equivalent equation then. Look at step 3. So step 3 is you're going to add or subtract variable terms to get all the variables on one side. All right, so it does not matter which side you bring the variables on. Make these a little bit easier on yourself. Which side do you think you may want to bring the variables on? The left? Okay, it does not matter. So if I'm going to bring the variables to this side, right now I'm subtracting 3x. What's the opposite? Adding 3x. I'm going to add 3x to both sides. Okay? So that was step 3. Okay? Now go to this part here, right here, and let's kind of remember some properties of equality. Properties of equality. Notice what I just did. I added 3x to both sides. What I do to one side, I do to the other. That's what keeps it balanced. So that's the idea of that property of equality. So what I'm using here is the addition property of equality. I'm adding a number, or I'm adding a term to both sides. That's the addition property of equality. Okay? All right. So I use the addition property of equality. Now the next step is to combine like terms. So I'm going to combine like terms again. So you combine like terms quite a few times. Like terms. What's 6x plus 3x? 9x plus 2 equal? Right, because when I combine these, what is that? 0. So I brought all the variables to one side, I combine like terms, and that's what I end up with. Now what's the next step? Bring the constants to the other side. When I bring the constants to the other side, right now I'm adding 2, and I'm going to do what? Subtract 2. And so when I use that property of equality, when I subtract 2 from both sides, what you do one side, you do the other. Now remember, you got to show both, right? So if you do this that I'm pointing at, let's say you subtract 2 only from the other side, is that mathematically correct? No, because now you're saying 9x plus 2 is 9. Is that true? No, that's not true. So you got to subtract 2. So make sure you show both ways. That's mathematically correct. Combine like terms, what do you get? This is 0, so what do you get on this side?
9.
Equal? 9. So 9x equals 9. Yeah, so the next step, if you go back to that first page, so you're going to isolate the variable by dividing both sides of the equation by the coefficient of the variable term. So right now, multiplying both sides by 9, what's the opposite? I'm sorry, multiplying x by 9, what's the opposite? Divide. Just like this. We do one side, do the other. 9 divided by 9 is 1. 1 times x is x. So what's your solution? 1. So you found equivalent solutions, because all of these equations that I'm pointing to, all of them, is going to have what solution? X equal 1. So how many solutions does this equation have? Just one. Just one solution. You're not asked to graph it at all. It's just one solution. In fact, you wouldn't graph it in a plane anyway because you don't see a y. The previous one, though, where you had two variables, you had an infinite number of solutions, so you had to graph it. All right, so any questions on the steps? Okay, let's look at another one. Suppose we had this one. All right, so this was number 1. Let's look at number 2. So number 2, let's suppose my equation is this. 16 equal 3 times x minus 1 subtract x minus 7. I write that down. So 16 equal 3 times x minus 1 subtract x minus 7. So step 1 is to get rid of the parentheses if you have any, and I do. How many sets of parentheses do I have? 2. So we use the distributive property twice. This one's easy. That one you're going to multiply by 3, right? Now look at the other one. You're going to multiply everything in here by a negative 1. Because if there's no number there, I'm going to rewrite it. If there's no number there, it's understood to be 1, right? So make sure you put a 1 if you need to. So you can distribute 3 here, and you can distribute negative 1 here. So I get 16 equal, what do I get? 3x minus what? 3. Tell me what the other one will be. Or just minus x, and then what? Plus 7, because a negative 1 times a negative 7 is a positive 7. Now what's the next step? Combine like terms. So I'm combining like terms at this point. All right, when I combine like terms, is there any, there's only one term on the left, right? So there's nothing I can do there. All right, how many terms do you see on the right? 4. Can I combine any of those? Yes, and let's put the variable first. So 3x and a negative x is 2x. A negative 3 and a positive 7 is 4. So 2x plus 4. All right, 2 more steps and you're done. What's the next step?
Minus 4.
Subtract 4 from both sides. So you're using the addition property of equality or subtraction property of equality, however you want to think about it. What's the next step? Combine like terms. So what's 16 minus 4? 12. Equal. This is 0, so what's left? 2x. And now I'm using the multiplication property of equality, so I'm going to divide both sides by 2. And so 2 divided by 2 is 1, so I get x to be 6. So that's your solution. So your solution is 6. All right. Okay, let's look at number 3. You have 2x minus 3 divided by 2 equals 3/4 minus, in parentheses, x plus 5 divided by 8. So,
You said parentheses or no? Did you say parentheses? Okay.
It's just what you see. Okay, so listen carefully to this. So notice, what's the difference between problems 1 and 2 and 3? Well, first of all, let me ask you this. Is this a linear equation? Yes, it's a linear equation. It's still a linear equation because x, all the variable x's are being raised to what power? The first. So that's linear. It doesn't matter that you have a number in the denominator. That's okay. But of those 3 linear equations, the first and the second were easy to deal with. The third one has fractions in it. Okay? All right. So what you want to do is this. And let me see if it's on this one as well. It is not. Okay. Well, actually it is. Okay, so you see on this part here where it says clearing fractions? See this right here? All right, look at this when it says clear fractions. All right. So you want to clear your fractions. So you want to get rid of those denominators. So basically meaning that you, instead of a 2 here, you want that to be a 1. Instead of a 4 here, you want that to be a 1. Instead of the 8 here, you want that to be a 1. That's what you want. Because if you think about the one we just did, when I got to this point right here, is 6x the same thing as 6x divided by 1? Is 2 the same as 2 divided by 1? Okay, so that's the idea. But to get rid of all these denominators, to make those 1s instead of what you see, you got to find the least common denominator. All right, so that's what that says. To clear the fractions, you multiply both sides of the equation by the LCD. See, LCD meaning least common denominator. So least common denominator means this. What's the least means smallest? What's the smallest number that 2, 4, and 8 go into evenly? 8. No, not 2. 8 doesn't go into 2 evenly. The LCD has to be bigger than or equal to the largest number you see. So my LCD has to be at least as big as what? 8. Your least is what? 8. Let's talk about CD, common denominator. Could someone had used 16 to multiply both sides by? Yes, they could have used 16. Any number that these will go into. So there's quite a few. There's an infinite number. But you want to use the least. So it's the smallest number that 2, 4, and 8 go into. 8. All right, so the LCD is 8. All right, now here's what you're going to do. Okay, so you're going to multiply both sides by 8. That's the multiplication property of equality. What you do to one side, you do to the other, right? All right, so the next step is this. You have on the left side, you see you only have one fraction that you see? This is one fraction. You have a numerator and a what? Denominator. That has to be multiplied by what? By 8. What you do one side, you do the other, right? On the other side, how many fractions do you see? 2. You see 2 terms, basically. This one and this one. You need to put that in parentheses. Now, the reason I'm putting parentheses is because of this. Remember, I've got to multiply both sides by what number? 8. So I multiply this side by 8, and I multiply this side by 8. But every fraction here that you saw, every term that you saw, had to be multiplied by 8. So that's why you need a parentheses there. I did not need parentheses here. I did not need parentheses here because that's just one fraction. Okay? All right, now, notice the reason you're multiplying both sides by the LCD is to clear the fractions. So now we're going to reduce. Remember in the beginning of class we talked about reducing? 2 to 2 is 1. 2 and 8 is 4. Okay. All right. Now, be careful here. This is what some of you are going to do. Some of you are going to say 4 to 4 is 1, 4 to 8 is 2, and then you can distribute the 2. That's incorrect. Because both of these have to be multiplied by what? Both of these have to be multiplied by 8. So if you reduce first, you're getting an error because 4 into 8 is 2, but now you're multiplying this by 2. That needs to be multiplied by what? 8. So be careful. So you can distribute. So you get 4 times 2x minus 3 divided by 1. I'm just rewriting it over. That's all I'm doing. Just rewriting it over. Equal, and then that's going to be 8 times what when I distribute? 3/4 minus 8 times what? X plus 5 over 8. All right. So that's what I have at this point. That's what I have. Okay? All right, now, be careful here. See, this is where somebody's going to make a mistake. Do y'all agree that first of all, 2x minus 3 divided by 1 is 2x minus 3? Okay. But think about what's happening here. Am I multiplying just 2x by 4? No. What else would be multiplied by 4? Negative 3. So you got to put that back in parentheses. You have to put it back in parentheses. So in this problem where you have fractions, you have to insert parentheses. You are going to have to insert them. So now you distribute again. So what do I end up with on this side? 8x minus 12. 8x minus 12. All right. Over here, just reduce. 4 to 4 is 1. 4 to 8 is what? 2. Now that one's easy. What's 2 times 3? 6. All right. So that was no big issue. That was just 6. Okay, be careful here. That kind of looks like this we just did. When I reduce, 8 and 8 is 1, 8 and 8 is 1, but be careful. It's negative 1 times what? X plus 5, so you got to put that in parentheses. And now distribute the negative 1. So I get negative x and then what? Minus 5. Okay? So there are quite a few places you could have easily messed up. And now I've gotten to the point where it's easy to deal with. What's the next step? Once you get to the point, the rest is easy. What's the next step? Combine like terms. And the only side you can combine like terms on right now is just the right-hand side. And let's put the x first. So I'm going to get 8x minus 12 equals what?
Negative x plus x minus 5.
No. 1.
Plus 1, right?
1.
Negative 6 and negative 5 is 1. Okay? Combine like terms. All right, now, the next step is where you bring all the variables one side, constants the other. So let's bring the variables to the left side. So how do you get rid of this negative x? What are you going to do? Add x to both sides. So add x, just like this. Make sure you show it both. Make sure you show it twice. Plus x plus x. Okay? Now, what's the next thing I got to do to those combine like terms? So what's 8x and x? Minus 12 equal, this is 0. What are you left with? 1. Okay, what's the next step? Add 12 to both sides. Combine like terms. End up with 9x equal, I'm sorry, I said 12, right? End up with what though? 13. What's the next step? Divide both sides by 9. You found your solutions. So x equal 13/9. You can leave it as an improper fraction. You have to write it as a mixed number. Okay? Let's look at one similar again. We're going to do one more like this. Suppose I had this. I'm making this up. Suppose I had 3x minus 4 over, let's say, 6 minus 2/4 equal x plus 3 over, let's say, 2. right, now, you have fractions. First of all, is this a linear equation?
Yes.
That's just a linear equation. What's the LCD? 12. The LCD is 12. Not 6, not 4, not 2. 12 is the smallest number that 6 goes into, because 6 goes into 12 how many times? 2. 4 goes into 12 how many times? 3. 2 goes into 12 how many times? 6. All right. Now I want you to notice something. You remember when we did the previous problem, we put this side in parentheses? Okay. I want you to notice though, after that step, what happened, remember the idea is that every term had to be multiplied by what? 8. So notice when I got to this part, you see this right here? That's this, right? Times 8 right here. That's this right here. When I got to this part, 3/4, that's 3/4 times what? 8. X plus 5 over 8 times what? 8. So if you want to skip this part and go directly from here to here, you can, but here's what you're going to do. You're going to say this. In your mind, you know you're multiplying both sides by what number? 12. So the LCD is 12. Which means both of these sides have to be multiplied by what? 12. Which basically means that every term has to be multiplied by what? 12. So this is what you have. You have 12 times 3x minus 4 divided by what? 6. Minus 12 times what? 2 over 4. Equal 12 times what? X plus 3 over 2. And I should not have used 2/4 because 2/4 can reduce, right? So let's use 1/4. Let's just change to 1/4 because you could have reduced that and gotten 1/2. In that case, the LCD would have been what? If this was 2/4 and you had reduced it, the LCD would have been what? 6. But, so go ahead and change the 2/4 to 1/4 instead, so we can keep the LCD to be 12. So that's 1 right here. Put that as 1. All right. Now what I would do next is this. Remember, in this point right here, at some point we had to put parentheses around that numerator because it had more than one term in it. Then I would do the same thing here. Put that in parentheses and put that in parentheses. That's what I would do. Okay?
So why did we combine
Why do we what?
never mind.
Okay. All right. Now, why is it I didn't put that one in parentheses? Because it's just one term. That is going to be multiplied whatever this is reduced. Okay? All right. So, remember, the whole idea of multiplying by 12 is to get these down here to be 1s. 6 into 6 is 1. 6 into 12 is 2. And then you would distribute the 2. 4 into 4 is 1. 4 into 12 is 3. 2 into 2 is 1. 2 into 12 is 6. And you distribute the 6. All right. So then what do we get over here? Minus what? 8. Okay. Minus 3 equal 6x plus 18. Good. That's what you get. All right. What's the next step? Combine like terms. I get. All right, good. So a -8 and a -3 is a -11. So 6x minus 11 equal, 6x plus 18. Doggone it. You'll see what's going to happen. It's all right. We can talk about it now. All right. So now what do you do? Yeah. So notice what happens when I subtract 6x from both sides. Yeah. So I get 6x subtract 6x is 0 when I combine like terms. And I get -11 equal 18, right? So that's a false, first of all, that's a false statement. That's a false statement, right? So notice a variable disappeared. Variable disappeared. That's a false statement. -11 does not equal what? 18. So since a variable disappeared and that was a false statement, we're going to say no solution.
So, what if you
Okay, so the other way you can write it is this. On my math lab or on the worksheet, you could then say this. You can remember that little symbol here means the empty set. So you can use that instead as well. So no solution. I did not mean to get to that point. Remember, I just made it up and it just happened to be no solution. We were going to talk about that in a different part of this lesson. We'll come back to that one when we get to it. But no solution. That's a false statement. Negative 11 does not equal 18. Okay? So that equation had no solutions. All right, let's look at this one. So this is going to be number number 5. So number 5 will have a solution. X plus 3 divided by 3 minus 1 equal 3 halves plus x minus 5 divided by 6. So x plus 3 divided by 3 minus 1 equals 3 halves plus x minus 5 divided by 6. Is that a linear equation? Yes. I have fractions, so we got to clear the fractions. What's the LCD? 6. The LCD is 6. So you're going to multiply both sides by 6. So this by 6, this by 6, which basically means that every term that you see has to be multiplied by 6. So this fraction, x plus 3 divided by 3, has to be multiplied by what? 6. Minus, see this 1, that has to be multiplied by what? 6. That's where some of you mess up. You forget about that 1 as well. Equal 3 halves, that has to be multiplied by 6. And then plus x minus 5 divided by 6, that has to be multiplied by 6. So every term has to be multiplied by 6. So you have this term, this term, this term, this term. Okay? Knows the difference between number 5 and number 4. When we did number 4, how many terms did you see? 3. So notice I said times 8, times 8, times 8. I'm sorry, 12. Times 12, times 12, times 12. Here there are 4 of them. So all 4 had to be multiplied by the LCD, which is 6. Now, this first term, the numerator, is a binomial, so put that in parentheses. That's just a 1. That's just one thing, so leave that alone. This is a 3. Leave that alone to put that in parentheses. This has 2 things in it, so put that in parentheses. All right, now reduce. The whole point of multiplying by the LCD is get rid of those denominators, to make those denominators 1s. And I do. 3 to 3 is 1. 3 to 6 is 2. And then I distribute the 2. Over here, 2 to 2 is 1. 2 to 6 is 3. Over here, 6 to 6 is 1. 6 to 6 is 1. And I distribute the 1. All right, let's go back over here now. What's 2 times x plus 3? 2x plus 6. Minus what? 6. Equal 9 plus x minus 5. Is that correct? Okay, so that's what I get. What's the next step? Combine like terms. Combine like terms. On the left side, what do I get? 6x's add up to be 0. I'm sorry. The 6 and negative 6 add up to be 0. So you're left with 2x. Equal. Over here, that's x. Put x first. Plus 4. One more step and you're done. Not 2 steps, but 1 more step. What's the next step? Subtract what? X from both sides, just like this. Then combine like terms. That's 2x minus x. Equal, that's 0. What does that equal? 4. So there's your solution. So your solution is x equals 4. Okay? All right, question at this point. All right, so we're going to go ahead and take a 10-minute break. Hold on.